So note that sometimes people will kind of use parallel and distributed programming interchangeably. They're technically different things, so we'll kind of make that little bit of distinction. So I think the curriculum kind of goes through it, so I'm not going to dwell too much unless you guys have questions. But basically, distributed programming is essentially where you have multiple CPUs, so basically multiple brains, working with each other. Usually we say they have their own memory, so they're basically working separately from each other. And then they can share this information either through like a single server. So you can see like this big computer essentially aggregating all the information to one server, or some systems actually will just have what they call peer-to-peer networks. So you can actually have like the information being processed on a computer and it shares it with each other. Both these systems would be distributed networking. This one tends to be more classically done just because I think the human brain like does a pretty good job on like saying, oh, there is a central authority that is collecting all the information go through here. But peer-to-peer networks definitely have gotten really interesting in how you kind of make that work. Some famous examples are things like the torrent protocol, for example, uses basically a protocol where essentially you're doing different things and you're sharing amongst peer-to-peer. There's no central network no central server. Other stuff like cryptocurrencies like Bitcoin and stuff like that too. Those things work on a peer-to-peer network, but you can also have something like a very like much more mundane thing like IoT, like Internet of Things, smart home kind of stuff, where you have maybe something that's connecting with each other before it talks to a central server too. So there's a lot of different ways like this can kind of come up. Okay. So that's distributed networking. Kind of comparing it with, like, before we go into parallel processing, is that remember, all we talk about with distributed just means there's multiple computers working on different problems and communicating in some way. Sequential programming or sequential processes basically take one step at a time. So this is directly from the curriculum. We take a problem, there's a bunch of steps, you do a bunch of steps, step one, you know, going through, and then it's, oh, here's step 2, step 3, step 4, CPU. So the problem is that if it takes a long time to do step 2, it's kind of like you got to wait until step 2 is completely done before you do step 3. So, you know, some problems you just have to do it this way, right? There's no other choice, essentially. It's like, for example, think of like XGBoost when we were talking about that machine learning algorithm, is that you had to basically do the previous one before moving on to the next part, right? Like there's not a choice. That would be traditional sequential processing. But there's some problems that you can actually modify or say, hey, you know what, I can do this. Instead of sequential, like step 1, step 2, step 3, you can do something in parallel. So basically the idea here is that you take the problem, and I don't think this is the best way to kind of show this, is that I think you should think of like one big problem. But you can think of like one big problem split into different like sub-problems, right? So these are kind of like little sub-problems, and you have multiple CPUs working on each of these tasks at a time. So one thing I kind of do an example of this is back when I was teaching, I had a lot of like grading papers sometimes to do. And sometimes, you know, for example, one big task like I always thought was kind of an interesting one is like putting in alphabetical order so you can like actually submit it in your grade book. So you might have like 300, you know, students, and you're like, okay, I got to submit this in alphabetical order and stuff like this. And sometimes this would happen when, like, I remember they're like standardized testing, and the teachers basically, we'd get all the tasks together and like we'd have to sort them together by grade and by alphabetical order and all these things. And if one person were to do it, it would take forever, right? But you can actually do things where you can sort them in alphabetical order, even if you don't have like all of the ones in the same grade, by basically splitting up. Let's say you have grade 5 and you split up. He's like, okay, here's part of grade 5, here's part of grade 5, here's part of grade 5. And each person can sort them all together within their own groups. And then you can basically, there's an algorithm called merge sort, where basically you can combine this, like once they're alphabetized individually, you can then combine them together. So that's kind of what parallel processing is. Like, well, okay, it doesn't matter. We don't have to organize the whole thing at once. Like, you know, find the first letter and then find the second, you know, or the first person, the second person, the third person. We can do relative like small parts. And that would be parallel processing, where essentially you have a little task over here, a little task over here, a little task over here, and then combine them at the very end. Or, you know, possibly, you know, for example, I'm trying to think of a good one of this. If you had something like, okay, we need to know what's the total score, what's the average, I don't know, age, you know, something like that. It's like, well, you might have to go, if you were to do sequential, you'd look at all the papers going through and saying, okay, here is all the scores and adding them up as you go through. And then you're done with that. And it's like, okay, let me look at the age and go through all the ages and then figure out the average. Where, you know, you could potentially kind of have like 2 copies and essentially say, hey, you do the average for the age and you do the total score. And that way you can kind of do it at the same time. And so even though together it might take more time, if that makes sense, realistically, it's going to go faster because you don't have to do one thing and then the second thing. You can do them, the first and second thing together. Does that make sense? Okay. I think overall parallel processing, as you get into more like algorithms and stuff that does this, I don't think the brain like works in this way. I mean, like I should say, I don't think our human brain like really thinks in the way of like saying, oh, how do we parallel processing? But a simpler example of this would be like, oh, I can turn on the dishwasher and the washing machine at the same time. It's like, hey, I'm doing parallel processing versus waiting for the dishwasher to wait, like complete, and then, oh, dishwasher is complete. Let me go do the laundry now. So kind of do parallel processing. Anyway, all right. Any questions about differences between distributed, sequential, or parallel processing?
I have one question.
Yeah.
So it's distributed, I'm trying to like get it straight in my head. So distributed is a completely different thing than sequential and parallel, right?
Right. Yeah. Distributed is kind of more like saying a way to attack a problem. It usually means we're doing things in parallel. Like you could do sequential programming with a distributed network. For example, let's say this computer does step one, passes it to the server, and then the server goes, okay, here, I got step one completed. I need this information, pass it over to this computer and do step two. So maybe these computers can do different things separately, but that would still be sequential. And you'll probably notice that's probably pretty slow going like in that direction. But usually when we talk about distributed networks, we're usually talking about parallel because then each one of these computers can do something and then combine them together. Does that make sense?
Yeah, that's helpful. I guess I was getting confused if it was like 3 different ideas and then like one is happening, but I get it now. It's like distributed and parallel, or distributed and sequential.
That's right. Yeah. And you might say like, someone might go like, why would I do sequential on this? This might be something like you have to pre-process the data before you do anything else. So you might have to split up this information, do the pre-processing. Let's say these two computers are really good at pre-processing data for whatever reason, and then it passes to the server, and then the rest of the computers would do the next steps in parallel or something like that. So you can see sequential happen in distributed systems, but usually we think distributed and parallel together. Okay, cool. All right, good. I'm glad we got that. So last part, basically, before we go into like anything like MapReduce and all that stuff, is I just want to talk about distributed systems, like what do we use for tools? So some basic tools, like you can see here, I think this is from the curriculum itself, is that you can see all these different tools, for example, visualization, analytics. So this is less about like big data by itself. And then this is when we talk about like down this part right here, where computation, storage, and distribution data warehouse. These things are going to be really like, what's it called? There's so much you can do. There's so much like different technologies, and like, I swear, it sounds like when you're talking to something, like, oh, do you use Hadoop? It's like, oh, I use Hive on top of the HDFS, Hadoop system. I was like, oh, but Pig and Hive, and it just sounds really weird talking about it. But it's kind of useful to know a little bit of technology. These are definitely like a small like sliver of like what's out there to do things. So like, for example, we'll talk about Apache Spark versus Hadoop. We'll talk about like what those differences are. What's nice about a Spark is that, we'll talk about in a second, but Hadoop is kind of like old school in the sense that like it's been around for a while now, and Spark is kind of like the new kid on the block, but does a really good job. When we store things, for example, Amazon S3, you might have heard me talk about this before, like AWS, Amazon Web Services. S3 is a very popular storage thing, but you also have things like Redshift and other, I mean, you can go to Amazon, you can go to AWS right now and like look at all the different storage options they have and the ways they store things and why you would use one over the other. So there's a whole bunch of options here. And then distribution warehouse, for example, basically Cassandra is a way to process this information. Oracle, for example, has a lot of like big data, think more enterprise stuff. So like they've been around for a while. Cassandra is getting a little more popular in that sense, and I see that more and more commonly. But there's a whole bunch of technologies, and this is where I would say if you were going for the data engineering side of things, this would be closer to like what kind of like technologies you'd be more and more familiar with. And it's helpful as a data scientist to kind of know what's out there and how they're used. But don't feel like it's like, oh my gosh, I need to learn all of these different things in order to like do any of my data science stuff. That won't be true. Mostly you'll have something that's going to be a specific technology that's going to be used for whatever company or, whatever place you're working with. Okay, cool. So So not to intimidate you more, we'll talk about one specific part. It's Hadoop framework. Is a really like common one out there. It's old school. It's technically slower than what we'll talk about with Spark, but we'll talk about like why in the sense that doesn't really matter too much. You can note that basically one big part is storage, and usually we call it, usually it's referenced as HDFS. So this is actually stands for, let me make sure I get this right, Hadoop Distributed File System. So it looks just like a regular like file system. Like, you know, if you open up folders, you're like, oh, okay, I can see everything here. But what's really cool is that Hadoop basically works on distributed. So you can kind of imagine this as being like, if you have like little, if you have like one big thing of data, let me just do a quick drawing. You have one thing of data right here. And let's say this is like, I don't know, like 100 gigabytes, right? And I'm simplifying, this is not exactly how the Hadoop system works. I'm not gonna go into full details of like how they split it up, but he's like, okay, this is a whole big data. It's like, well, I don't want to store this in one place. I want to have this distributed out, you know, so maybe computers can do different parts of it. You'll start splitting this up into different pieces. So you might have something like, okay, let's chunk this into this purple piece right here. We'll split it up into this, I don't know, green piece right here. And then we'll do our last one. I don't know, what's a good color here? Light blue? Light blue looks good enough. Okay, so we have it like in 3 different chunks here. And then what happens basically, instead of having it in one thing, you split it up. So then you say, okay, like each, let's say we have different parts. We have this chunk, this chunk, this chunk. And what's interesting is that what we can do then is we don't have to have all pieces in each of these chunks. What we can do is just have portions of it. So for example, you say, okay, well, this one's gonna have the blue chunk, this one's gonna have blue chunk in here, and this one's also gonna have the blue chunk. And then maybe this other one's going to be in the purple. This is going to have purple here. This is also going to be here. And maybe, yeah, one right here. Okay. And then you might say, okay, like then we have, what's the last one? The dark green. So we have like, oh, here's dark green right here. And I don't know, let's just say there's a double copy right here. So you can kind of see a little bit is that it's spread out a little bit. So no one piece has all the information, but there's some redundancy built into there. So the idea here is that each of these live on a separate computer, separate server. Is that, let's say, for example, server breaks, you know, which computers, you know, if you have like 1,000 different servers, one of them is probably going to break just randomly, just out of hardware, but also network connection goes down. If this one, for example, goes down, you still have all the pieces and can still manage to get all the pieces as needed. So that's kind of what HDFS does. No, technically, I think it splits it up into 64 megabytes by default. So like that's kind of the different chunk sizes and stuff. Okay, cool. So that's the basics you really need to know for HDFS. If you're curious, you can probably search more and learn more about how HDFS works. And like, you know, there's something like a resource management system, which usually built around like Yarn, for example, is one of the things that are used. But basically it tells you like, where does each piece go, who gets what, and all that stuff, and how to find each of those pieces. And again, I won't go into full details, but there are things like name nodes and all these extra technical details. The data processing part is using MapReduce. This is where it gets kind of confusing. MapReduce is actually the programming part to access these files through Hadoop or HDFS, but we'll talk about what MapReduce is and trying to, when we're trying to access that information and processing it either through Spark or HDF or Hadoop. Okay, so that's basically the Hadoop. So the next kind of like comparison would be Apache Spark, which is what PySpark is built around. So I note that also Hadoop is built in Java. I believe Apache Spark is also built in Java, but we can use the PySpark to basically interact with it, so we don't have to worry about programming in Java directly. What's nice about this is that it's actually faster than Hadoop because it holds it in RAM, in memory. And so remember, RAM is faster, right? So it can actually process this thing a lot quicker. So what's kind of cool though, it's not like a completely new technology. You can basically build it on top of Hadoop, like, you know, Hadoop, HDFS, but also in S3, which is getting really popular. Like being able to access this part. Note that technically like Spark is like really taking off, and like I would say most businesses, if they're looking to start a new, you know, data system, they're looking to probably use Spark, unless they have very specific reasons to use Hadoop. But for the most part, it's not always like the best tool. And just kind of put it out there is that I think, I don't have a note in here, but I believe Facebook, for example, lots of data, right? They still use Hadoop. And the reason why is because they started with Hadoop. They have it on their system. Yeah, Spark is faster, but it's like, it's not really worth that much for them to completely change over their system. So you'll plenty of times bump into Hadoop, depending on who you're working with. But the new kind of like technology right now, the new shiny star is Apache Spark. So just kind of be aware of that. But remember, these aren't always the best tool. One thing you'll notice if you ever try using, what's it called, Apache's, using Spark, you'll notice that it tends to run a little slower, like if you use like Pandas. So like the reason why is because Spark is optimized for distributed systems and stuff like this. So that's part of the reason why, like, you can, like, I wouldn't say, oh, now that you know PySpark, you should only use PySpark. A lot of times it makes sense just to do it in Pandas because it's going to be like sufficiently faster, or significantly faster than Spark itself. And you'll need to use Spark when it becomes a scale where there's larger things where you think, okay, like now we have big data versus like medium-sized data or small data. Okay, cool. Though, again, you can use it in local mode like you guys have been doing in the curriculum and stuff like this. So, but I wouldn't suggest to use it unless you're like trying to test things out. Okay. Cool. Any questions on anything we've talked about, distributed network or Hadoop versus Spark? Okay. So that kind of gave a little bit of, I'm going to stop sharing this part because I'm going to share the next part. That kind of gave a little bit of example of like how these parts kind of come together. Hopefully that kind of gives you an idea in addition to what the curriculum kind of shows. But the next part I'm going to show now is kind of like, how do you do stuff with it? Which is like the big part is going to be MapReduce, which is kind of more of like a, how I say, like a, what do I call it? Like kind of like a philosophy of programming versus like saying, oh, it's like this specific, you know, way, like this is the code you write. It's more like saying, how do you approach this? So I'm going to show that to you guys next.